This is going to cover the Unit 6 review. In the video description link, you can find the link to this handout if you are not in the class. If you're in the class, you should have a copy of this handout. It's either green or pink, depending on what color paper you have. I'm going to go over for your response question number 1. You can also find helpful hints and tips and resources in your textbook. This is the Practice of Statistics, 6th edition, updated 6th edition. And let's get started. Question number 1. A humane society wanted to estimate with 95% confidence the true proportion of households in its county that own at least one dog. Interpret the 95% confidence level in this text. If you want to pause the video and try using this page hint, if you want to follow along and see if you can interpret it in context, and then we'll go over it in a second. The generic interpretation for confidence level is in repeated sampling, about this percent of all intervals calculated will capture the true parameter in context. So just think about if you do this many, many times, this percent of all the intervals that you capture using the same procedure and technique should capture the true proportion or whatever we're trying to estimate. The answer is if we make many, many 95% confidence intervals, we expect about 95% of them to capture the true proportion of households in the county that own at least one dog. So you'll notice here, after true proportion, I'm just throwing in the context. So that part's important there. You want to make sure that you define what we're working with. And we also want to say many, many intervals. So if we do this many times, about, but it's never like exactly. So we expect about 95% of them to capture the true proportion of households in the county that own at least one dog. So that many percent of your intervals. And that's with level. When you see level, that's what that's talking about. Your confidence level, in this case, 95%. All right, question 2, or letter B. The Humane Society selected a random sample of households in its county and used the sample to estimate the proportion of all households that own at least one dog. The conditions for calculating a 95% confidence interval for the proportion of households in this county that own at least one dog were checked and verified. They've already gone through the random, 10%, and large counts. The resulting confidence interval is as follows. Letter B. A National Pet Products Association claimed that 39% of all American households owned at least one dog. Does the Humane Society's interval provide evidence that the proportion of dog owners in its county is different from the claimed national proportion? And if you need a hint, you can go to page 539 and part C of the example on page 541. Pause the video and try it on your own. Okay, the answer to this is no. What you want to do with your interval when it's set up as the point estimate plus or minus your margin of error, remember this is your point estimate and your margin of error, is you want to get the low end and the high end of the interval. And you can do that by simply subtracting and adding. So you'll see your interval actually ranges from 0.9298 to 0.536. And if you look at the question, we're looking for 39%, which is 0.39. Well, it just so happens that 0.39 falls in the. So in this case here, since it falls in the 95% confidence interval, then 0.39 would be considered a plausible value. Therefore, we do not have convincing evidence that it's otherwise, that it's different than the claimed proportion. Try letter C. How many households were selected in the Humane Society sample? Show how you obtained your answer. And if you need to find a hint, you can go to page 561 and 562 of your textbook. Pause the video and try it. I'm going to walk you through the steps on this one, which is why I only have the generic formula written down. Remember, for a confidence interval, for a one proportion, the margin of error is the Z star times the standard error formula, which is the square root p hat 1 minus p hat over n. Now, in this problem here, we're actually provided the p hat and the margin of error. If you go over here, that's your p hat, that point estimate. And your margin of error is what's after the plus or minus sign. So I just call that ME. And we should all know by now that your Z star for 95% confidence is 1.96. We're trying to find what the sample size is. So let's go through the steps of solving that. I'm going to first just plug in everything I have. So I'll say 1.96 square root 0.417, 1 minus 0.417. Close that up. Since we don't know n, we'll put that over n. And we'll say it's less than or equal to 0.119. Of course, you can guess and check, but that's going to take you probably longer than you're willing to have time for on a free response question. So let's act quickly. The first step is to be divide by 1.96. That's going to get rid of that. And so then you'll have the square root 0.417, parentheses 1 minus 0.417. Over n. And I'm going to go ahead and put that in the calculator. So when you get your graphing calculator, you're going to want to do these steps all together. So we'll do 0.119 divided by 1.96. And just press enter and leave that alone. The next step is to undo the square root. So you'll square both sides. And what I do here is I leave that in here, and I just go down here and I press the x squared button. So press x squared, that'll just take your previous answer and square it. You can also scroll up and do that. And now we'll have our squared value as 0.003686. Now it's important that you do not round, okay? We don't want to round along the way, so we're going to leave that answer the way it is. So finally, when I do the rest of my equation, we got to remember that this is really an inequality. That this square root's gone, so it's going to be 0.417, 1 minus 0.417 over n equals 1.119 over 1.96 squared. What we want to do is we want to take this number up here and divide by this and bring the n up. So at the end of the day, it's kind of a messy inequality, but at the end of the day, the n's going to go over here. This will still stay less than or equal to, and we want to bring that down. So you should see 0.417, 1 minus 0.417, divided by all of this, 0.119 over 1.96 squared. If you're not given, sometimes you're not given a proportion. So in that case here, you'd want to use 50%. But in this case, we actually have our value. So what I do is once I write all that down, I go into my calculator and I type the top part, 0.417, parentheses, 1 minus 0.417, close it up, and I divide, and I just scroll up. Press enter, and that'll be your number as a decimal. Now you cannot have a sample size that's a decimal. So we want to say n is greater than or equal to 65.95. Now, it doesn't matter if it says 65.1 or 65.99, you're going to always round up. So your final answer would actually be 66. We're going to round up. And we're going to say n should be 66. That's the minimum sample size we could get away with in this case here to get our margin of error within 0.119. And so we can verify that. If I were to go through and plug the numbers back in, I would have 1.96, the square root, 0.417, 1 minus 0.417, and then we got our answer to be about 66, so I'll do over 66. And that should give you 0.1189, which is going to be right around that 0.119 margin of error that the calculation gives. So thank you for watching. That was free response question number 1. The next video we'll go over free response question number 2.